Today, we're going inside the extreme recycling process of the American M109A6 Paladin Howitzer. Welcome to Factory Founder, LEP, where we explore the world's most powerful machines, extreme factories, and incredible manufacturing processes.
Across a vast industrial landscape under the open sky, thousands of rusted war machines sit silently in long rows. Once symbols of military power, these machines now wait for a very different mission. This is the graveyard of the American M109A6 Paladin self-propelled howitzer, one of the most powerful artillery systems ever deployed on the battlefield. For decades, these massive armored vehicles carried a 155mm cannon capable of launching precision firepower across miles of terrain. Built with thick ballistic steel, complex hydraulic systems, and powerful engines, each Paladin once represented cutting-edge battlefield engineering. But after years of service, upgrades, and replacement by newer systems, many of these artillery vehicles are retired. Instead of rusting away in storage fields, they are sent here. A massive open-air military recycling facility designed to safely dismantle and process some of the toughest machines ever built.
Watch her step on the flatbed. Steady as she goes. Make sure the chains are tight. They look good here. Get ready to move the first load. Copy that.
Yet even in retirement, the Paladin remains an engineering giant, weighing more than 27 tons and built from thick armored steel designed to survive battlefield conditions. Upon arrival, each vehicle is carefully unloaded into the vast outdoor staging yard. Here, hundreds, sometimes thousands, of retired Paladins wait in organized rows. Workers perform a visual inspection, identifying structural condition, corrosion levels, and missing components. Each vehicle receives a tracking tag that will follow it through every stage of dismantling. This allows technicians to monitor materials recovered from each machine. Once catalogued, the vehicles are moved deeper into the yard, where the real dismantling begins. Before any tools touch the vehicle, safety comes first. Even though the Paladins are retired, they still contain systems that must be carefully neutralized. Technicians begin by disconnecting remaining electrical systems. Battery compartments are opened, and any residual electrical power sources are removed to prevent accidental activation. Next comes fluid draining. Hydraulic oil, engine coolant, lubricants, and fuel residues are extracted using specialized pumping equipment. These fluids are collected in sealed containers for proper industrial recycling. Fire suppression components, pressurized cylinders, and any remaining gas systems are also safely removed. The final safety check focuses on the weapon systems. Although the howitzers arrive disarmed, technicians verify that the firing mechanisms, breech systems, and ammunition compartments are completely empty and safe to handle. Only after these safety procedures are completed can dismantling begin.
Almost free here. Keep it steady. Down a little further. Balls down. Watch the edges. Good. Take the tension.
The next step focuses on stripping away the external components attached to the armored hull. Workers begin with large bolted armor panels and protective covers mounted around the turret and hull sides. Using heavy impact wrenches, technicians loosen massive rusted bolts that have held these plates in place for decades. Once released, cranes carefully lift the heavy steel panels away from the vehicle. Next come the communication antennas and targeting equipment mounted on the turret. These systems once allowed the Paladin to receive targeting data and coordinate artillery fire. Now, technicians detach their brackets and wiring harnesses. External weapon mounts are removed next. Machine gun brackets, targeting sights, and other accessories are unbolted and lifted away. Along the hull sides, workers dismantle storage compartments, side skirts, toolboxes, and climbing ladders. The Paladin's mobility system is one of its heaviest mechanical components. Each vehicle moves using massive steel track chains supported by multiple road wheels and suspension arms. Technicians release the master links holding the track chains together. The massive steel tracks collapse onto the ground with a thunderous metallic crash. The centerpiece of the Paladin is its 155mm artillery cannon. Built from extremely durable weapon-grade steel, the cannon must be dismantled with precision. Workers begin by securing the long barrel onto reinforced cutting platforms.
Hold tension. Slowly. Easy. Keep going. Stop. Right there. Clear the turret. Steady. Keep it steady. Looking good up there. Slowly now. All right, slowly up. Next attention. Keep it steady. Guide it slowly to the right. Copy that. Moving right. Watch the recoil chamber. Almost there. Just a few more feet up. Keep it steady. Looking good. Almost got it. Ready with the wrench. All right, start cutting. Got the wrench ready. Needs to come out to the left. Push it toward the center.
Using industrial plasma cutters, technicians slice the barrel into manageable segments. Each cut sends sparks cascading across the steel surface.
Watch your hands. We're on target.
Next, the breech mechanism is removed. This heavy mechanical system once sealed the rear of the cannon during firing. Technicians detach locking arms, rotating breech blocks, and associated mechanisms.
Slowly now.
With the weapon systems removed, attention turns to the vehicle's engine compartment. The Paladin is powered by a large military diesel engine connected to a complex transmission system. Technicians open the engine bay and disconnect the remaining fuel lines, cooling systems, and electrical harnesses. Large cranes then lift the entire engine block from the vehicle's hull. Despite years of rust, the heavy cast metal components remain extremely durable.
Keep it steady. Watch the chains. Clear. Bring it up slowly. Engage the hydraulics. Okay, slowly. Keep it steady. Monitoring pressure. Looks good. Almost out. Keep guiding it. Lift it slowly. Keep it steady. Guide it this way. Watch your hand. Lower it now. Keep it steady. To the right, just a bit. Good, slow down now. Looks clear. Bring that plate over to the green bin. Roger that. Keep it steady. Clear that piece. Almost through. Keep it steady. Guide it to the right. Copy that. Coming down now. Watch your feet there, B. Got it. Slow and easy. Lowering the bars. Watch for the alignment. Coming down slowly. Position is good. Secure the load.
Each component is transported to sorting zones where metals such as aluminum, copper, and steel are separated. With the engine gone, the Paladin is reduced to its armored structure.
Torque wrench is set. Cutting tool ready. Loosening now. Cut is clear. Signaling crane. Engaging hoist. Lifting section. Up and away. Keep it steady. Down slowly. Lower the forks now. Watch the clearance. Secure the straps.
Now comes one of the most demanding stages. The armored hull of the M109A6 Paladin is built from thick ballistic steel designed to resist enemy fire. Cutting it apart requires powerful industrial equipment. Plasma cutters begin slicing through the large armor plates that form the vehicle's sides and top. Molten sparks spray across the cutting pad as the steel yields. Hydraulic shears are then used to separate the hull into large sections. Workers extract internal support frames.
The copper and aluminum are separating nicely. Keep an eye on the steel flow.
Datslet bonsai silinjen eines penis stager bekeincher sein the minte jers lar hennes si bettis some of the wool. You know the firm bamaket de die dakest.
Engage the primary press now. Copy that. Descending. Clear the bins below. Hydraulic pressure holding steady.
Engaging the press.
Stand clear.
Plates are bending. Maximum pressure.
Witness the might of the machine.
At the final processing stage, workers inspect the recovered materials. Steel fragments from the armored hull form the largest portion of recycled metal. High alloy steel from weapon components is stored separately because of its industrial value. Copper wire and aluminum engine parts and mixed alloys are sorted into designated storage zones. Forklifts and cranes move the sorted metals into organized stockpiles across the yard. Each pile represents tons of recovered material, ready for the next step in the recycling chain. The final step of the process is logistics. Workers load the sorted metal materials onto transport trucks and rail containers. These shipments will travel to steel mills and smelting facilities where the metal will be melted and reused. What once formed the armor and artillery of a battlefield machine will soon become something entirely new. Steel beams, industrial equipment, construction materials. The transformation is complete. The American M109A6 Paladin self-propelled howitzer was designed for one purpose: battlefield artillery power. But even the most advanced machines eventually reach the end of their operational life. Instead of becoming abandoned relics, these massive vehicles are carefully dismantled through an incredible industrial process. Every bolt, plate, and beam is removed with precision. Every material is recovered and recycled. In the end, thousands of tons of armored steel are returned to the global supply chain. War machines become raw material. Industrial engineering replaces military engineering, and the cycle of steel continues.